Hello there, and welcome to the Dozing Explorer. I'm so glad you found your way here tonight. There is a soft, quiet space waiting for you, a place to let the weight of the day simply drift away. Settle in and let your body feel the support beneath it. Let each breath be a little slower, a little deeper than the last. Tonight, we won't be going on a structured journey with a beginning and an end. Instead, we'll simply wander into the quiet, starlit ideas of relativity. We won't be studying or memorizing, but rather drifting through the concepts as if they were gentle currents in a vast, calm ocean. We will explore the silent, invisible fabric of the universe and listen to the way time itself can flow like a river, sometimes fast and sometimes slow. This is not a lecture, but a lullaby of cosmic wonder. We'll imagine the gentle curve of space around a sleeping planet and watch as starlight bends like a reed in a soft breeze. We'll float through the idea that everything you see in the night sky is a message from the distant past, carried on silent wings of light. We will feel the universe as a vast, breathing entity where space and time are woven together into a single, shimmering tapestry. It is a world of quiet, profound beauty, waiting to hold your mind as you drift. And if these gentle journeys and quiet explorations help you find your rest, you might consider subscribing. It helps others who are seeking a peaceful place to drift here as well, joining our quiet community of explorers. There is no need to do anything now, just a soft thought to hold for a moment before letting it go. For now, your only task is to rest. There's nothing you need to do, nowhere you need to be. You don't need to understand or even follow every word. Let my voice be a gentle anchor, a soft rhythm in the background. If your mind wanders, that's perfectly fine. Let it drift. If you fall asleep, that is wonderful. Just let yourself soften as the journey begins. There is a hidden fabric to the universe called space-time. It is something we cannot see or touch, yet it is as real as the ground beneath you. Imagine a vast, infinitely large sheet of the softest silk, stretched out in every direction into the quiet darkness. This is the fabric of space-time. It isn't empty, but rather a dynamic and responsive landscape that underlies all of existence. Every single thing with mass, from the smallest grain of dust to the most immense and ancient galaxy, rests upon this fabric. It holds everything, supports everything, and connects everything. It is the stage, but it is also one of the actors. The universe does not simply exist in this space. This fabric is the shape of our universe, bending and curving in a slow, silent dance. It is the context for every movement, every moment, every star that shines. It is the silent, invisible stage on which everything unfolds, every star, every planet. And even your own body creates a gentle dip in this fabric. Think of that vast silken sheet of space-time once more. When you place a heavy object upon it, the fabric gently sags and curves downwards around the weight. In the same way, the great mass of our sun creates a vast, sloping valley in the fabric of space-time. The Earth, being smaller, creates a smaller dip, a gentle dimple within the larger valley of the sun. Even you, resting here, create an infinitesimally small, almost imperceptible indentation in this cosmic material. It is a quiet and profound connection you have to the universe. Your very presence, your physical being, has a shape in this unseen dimension. You are not just in the universe. You are a part of its very structure, gently shaping the reality around you in your own small way. Your presence is written into the geometry of the cosmos. Gravity is not a force that pulls, but a curve in the landscape of reality. We often think of gravity as an invisible rope, pulling the Earth around the sun or pulling an apple to the ground. But in this quiet new understanding, there is no pull at all. Imagine a small marble rolling across that stretched silken sheet. If the sheet is flat, the marble rolls in a perfectly straight line. But If a heavy ball is resting in the center, creating a deep curve, the marble's path will bend. It will begin to circle the heavy ball, following the slope of the indentation. The marble is still trying to go straight, but the very ground beneath it is curved, guiding its path into an orbit. This is gravity. The moon is not being pulled by the Earth. It is simply following the straightest possible path through the curved space-time that the Earth has created. It is a silent, cosmic ballet choreographed by the shape of space itself. You are, at this very moment, traveling through space-time at an incredible speed. Even while lying perfectly still, you are on a journey. Part of this journey is through space. The Earth is spinning on its axis, and at the same time, it is orbiting the Sun at thousands of miles per hour. The entire solar system, in turn, is sweeping through the Milky Way galaxy on a vast, slow spiral. But there is another journey you are on, a journey through the dimension of time. Every second that passes is a movement forward into the future. Albert Einstein realized that these two movements, through space and through time, are connected. Your speed through time and your speed through space add up to a constant, the speed of light. So as you rest here, nearly still in space, almost all of your motion is directed through the dimension of time, moving you steadily from one moment to the next. You are a quiet vessel, sailing on the unstoppable river of time. Space and time are not separate things, but two sides of the same cosmic coin. For most of history, we imagine space as a vast, static container, and time as a universal clock ticking away independently. Space was the where and time was the when, but this is not the full picture. They are deeply and inextricably woven together. You cannot move through one without affecting your journey through the other. If you were to travel very fast through space, your journey through time would slow down to compensate. This unified four-dimensional reality is what we call space-time. To pinpoint an event in the universe, you need four coordinates, 3 for its position in space, like length, width, and height, and 1 for its position in time. Every event, from the flicker of a candle to the explosion of a supernova, has a unique address in this four-dimensional landscape. They are woven together into a single, shimmering tapestry of reality. The Earth orbits the Sun because it is following a straight line through curved space. It feels counterintuitive because we see the Earth's path as a beautiful, looping ellipse. But from the perspective of the Earth itself, it is doing the simplest thing possible, moving straight ahead. Think of an airplane flying over the surface of the round Earth. To a passenger, the plane seems to be flying in a perfectly straight line. But if you trace its path on a flat map, it appears as a long, graceful arc. The plane is following the straightest possible path on a curved surface. In the same way, the Earth is moving along the straightest possible path through the four-dimensional space-time that has been curved by the Sun's immense mass. It is a planet taking the path of least resistance, a path of perfect, effortless motion through a silent, invisible landscape. It is an orbit of pure geometry, a perfect circle in a higher dimension. A massive star warps the space-time around it like a heavy ball on a rubber sheet. Let us return to that gentle image of the stretched sheet. A star many times more massive than our Sun would create a depression in the fabric of space-time that is incredibly deep and steep. The slope of the curve around it would be immense. Any object, even a beam of light, that passes too close would find its path dramatically altered, bent by the sheer depth of this gravitational well. If the star is massive enough, the well it creates can become so deep that its sides are perfectly vertical. It punches a hole in the fabric of reality itself. This is what we call a black hole, a place where the curvature of space-time becomes infinite, a waterfall from which nothing can return. The star's great weight bends the universe into an inescapable shape. It is a monument of mass, sculpted from the fabric of the cosmos. The The shortest path between 2 points in the cosmos is not always a straight line. In the flat, simple geometry we learn in school, a straight line is always the shortest distance. But the universe is not flat. The presence of stars and galaxies gives it curves and contours, hills and valleys. Just as the shortest path for a ship sailing between 2 cities on a spherical globe is a gentle curve, the shortest path for a spaceship traveling between 2 star systems is a curve that navigates the dips and wells in space-time. This path, the most efficient and direct route through curved space-time, is called a geodesic. It is the path that light naturally follows. It is the path the planets follow. It is the universe showing that the most direct journey is one that respects the landscape. Nature always finds the most graceful path. This invisible fabric can ripple and wave like the surface of a quiet pond when 2 incredibly massive objects, like 2 black holes or 2 neutron stars, spiral into each other and collide. The event is so violent that it shakes the very fabric of space-time itself. The disturbance doesn't stay localized. It spreads outward in all directions, just like the ripples from a stone dropped into a still pond. These are gravitational waves. They are not waves traveling through space, but rather waves of space. As they pass by, they gently stretch and compress everything in their path, first in one direction, then the other. The effect is impossibly small, far smaller than the width of an atom. But with incredibly sensitive instruments, we have learned to feel these faint, ancient tremors from cosmic collisions that happened billions of years ago. It is the silent, resonant hum of the universe itself. A spinning black hole can twist the fabric of space-time around with it. Imagine a heavy ball spinning in a vat of thick honey. As it spins, it would drag the honey around with it, creating a swirling vortex. In a similar way, a massive, rotating object like a black hole or a dense star doesn't just curve space-time, it twists it. It grabs the fabric of reality and drags it along in the direction of its spin. This effect is called frame dragging. It means that the very definition of standing still is different near a spinning mass. Space-time itself is in motion. Any object, even a beam of light that tries to travel straight past it, would be dragged slightly sideways by this cosmic whirlpool. It is a subtle and beautiful confirmation that space is not a passive backdrop, but a dynamic, flowing substance. The universe is a place of silent, cosmic whirlpools. The simple act of falling is just you following the natural slope of space-time. When you drop something, it doesn't fall because of a mysterious pull from the Earth's center. It falls because the mass of the Earth has created a slope in the space-time around it. The object is simply rolling downhill along this invisible incline. An astronaut in orbit feels weightless not because they have escaped gravity, but because they are in a state of continuous, perfect freefall. They and their spaceship are constantly falling together along the curve of space-time created by the Earth. They are following the most natural path available without resistance. That feeling of weightlessness is the feeling of pure, unimpeded motion through the geometry of the universe. The feeling of weight you have right now is the chair or bed beneath you, pushing up against you, stopping you from following that natural downward path. Weight is just the feeling of something holding you back from your natural course. Your path through the day is a unique trajectory through 4 dimensions. From the moment you woke to this very moment of rest, you have been tracing a one-of-a-kind line through space-time. This line is called your world line. It records not only your movement through the 3 dimensions of space, left and right, forward and back, up and down, but also your constant, unwavering movement through the 4th dimension, time. If you could see it, it would look like a long, intricate thread stretching from your past into your future. Every person, every planet, every photon of light has its own unique world line weaving through the great tapestry. The paths may cross and interact, influencing each other's curves with their gravity, but each one is a distinct and personal journey through the whole of reality. Your life is a unique thread in the fabric of the cosmos. If space-time were perfectly flat, planets would drift in straight lines forever. Imagine a universe without any matter or energy. In such a universe, the fabric of space-time would be perfectly smooth, taut, and flat in every direction. There would be no gravitational wells, no curves, no dips or dimples. A planet placed into this universe and given a gentle push would travel in a perfectly straight line at a constant speed forever and ever. It would never turn, never slow down, never deviate from its course, because there would be no curves in the landscape to guide it. This is the universe as Isaac Newton first imagined it. But our universe is not empty. It is filled with the beautiful texture of stars and galaxies, and it is their mass that gives the cosmos its interesting and dynamic shape. The curves of the universe are what make the dance of the planets possible. The structure of the universe is written in the geometry of this cosmic fabric. The grandest questions we can ask: why galaxies form in clusters, why the universe is expanding, how light travels from distant stars, can all be answered by studying the shape of space-time. The equations of general relativity are, in essence, a set of rules that describe how the presence of matter and energy sculpts the geometry of space-time, and in turn, how that geometry tells matter and energy how to move. It is a deep and elegant feedback loop. The universe is not just a collection of objects, but a single, interconnected system where the stage itself is shaped by the actors upon it. The vast, web-like structures of galactic superclusters are simply tracing the gentlest, most welcoming contours of space-time on the largest possible scale. The cosmos is a story told in the language of curves and lines. Even empty space is not truly empty. It is filled with the potential of space-time. When we look at the vast voids between galaxies, we might think of them as true nothingness. But even there, in the coldest, darkest depths of intergalactic space, the fabric of space-time exists. It is still there, stretched and waiting. It has properties of its own. It can carry gravitational waves. It can be stretched by the expansion of the universe. And according to quantum mechanics, it is shimmering with a constant fizz of virtual particles that pop in and out of existence in moments too brief to measure. This empty space is a dynamic medium, a reservoir of potential. It is the canvas upon which reality is painted, and even without any paint on it, the canvas itself is real. Nothingness itself has a structure and a presence. The universe doesn't happen in space and time. The universe is space-time. This is perhaps one of the most profound shifts in perspective. We tend to imagine a pre-existing infinite empty box, and then we imagine the Big Bang happening inside one corner of it. But this is not the case. The Big Bang did not happen in space. It was the event that created space-time itself. Before that moment, there was no where and no when. The universe didn't expand into an empty void. Rather, the fabric of the universe itself began to stretch, creating more space and allowing for the passage of time. All of the space that currently exists was created in that expansion. The universe is not a container for reality. The universe is the sum total of the dynamic, evolving fabric of space-time and everything within it. It is a self-contained, breathing, and growing reality. The shape of space-time tells matter how to move. Consider again the planets of our solar system. Each one, from Mercury to Neptune, is following a precise and predictable path around the Sun. They do not have engines or a mind of their own. They are simply obeying the instructions given to them by the shape of the space they inhabit. The Sun's mass has created a specific set of contours like invisible tracks on a railway, and the planets are merely following these tracks. The same is true for a comet swinging in from the outer solar system, or a beam of light from a distant star passing near our Sun. Everything that moves is simply responding to the local geometry of the universe, taking the path of least resistance through the gravitational landscape. All motion is a form of surrender to the shape of the world. In turn, matter, and energy tells space-time how to curve. This is the other side of the beautiful cosmic conversation. While space-time directs the motion of matter, it is the matter and energy itself that creates the curves in the first place. A dense, compact neutron star will warp space-time much more intensely than a diffuse cloud of gas. The concentrated energy in a beam of light, though massless, also contributes its own tiny bit of curvature. This means the universe is constantly co-creating itself. As galaxies cluster together under their mutual gravity, they deepen the gravitational well they inhabit, which in turn encourages more matter to fall in. It is a dynamic, evolving dance between the contents of the universe and the container that is also a participant. The cosmos is constantly whispering its shape into existence. We can't see this fabric, but we can see the starlight that bends as it passes through its curves. One of the first and most beautiful proofs of this idea came from observing the stars. During a total solar eclipse, when the bright disk of the sun is hidden by the moon, the stars near the edge of the sun become visible. Scientists predicted that the light from these distant stars, as it passed through the deep gravitational well created by the sun's mass, would have its path bent. The stars would therefore appear to be in a slightly different position in the sky than they normally are. And when the measurements were taken, this is exactly what was observed. The starlight followed the curve in space-time. It was the first time we were able to see the effect of this invisible landscape, using ancient light as a tracer. The stars themselves became the ink that revealed the unseen page. The universe is like a great, silent sculpture made of space and time. If you could step outside of it all and perceive the four dimensions at once, you might see the entirety of the cosmos from the Big Bang to the distant future as a single, static object. It would be an unimaginably complex sculpture, with the world lines of every particle and planet and star forming intricate patterns within it. There would be great troughs and canyons carved by galaxies, and tiny little dimples from planets and people. Our experience of the flow of time is simply our consciousness moving through this sculpture, experiencing one slice of it at a time, from one moment to the next. But the entire sculpture, the whole of space-time, might simply be, all at once, in a timeless existence. It is a single, magnificent, and unchanging work of cosmic art. Time itself flows like a great river, moving faster in some places and slower in others. We experience time as a constant, steady beat, a universal rhythm ticking away at the same rate for everyone, everywhere. But this is an illusion born of our limited perspective. According to relativity, time is fluid and malleable. It can be stretched and compressed. In regions of the universe where gravity is very weak, such as in deep intergalactic space, the river of time flows very quickly. But near massive objects where gravity is strong, the river slows down, becoming deep and sluggish. Time itself is part of the physical universe, and it is affected by the objects within it. It does not stand apart as a neutral observer. It participates in the dance. There is no universal clock, only countless local currents in a cosmic river. A clock on a mountaintop ticks ever so slightly faster than a clock at sea level. This is a real and measurable effect. Gravity is slightly weaker at the top of a high mountain than it is down in a valley. Because of this, time flows just a tiny fraction of a second faster at higher altitudes. Scientists have tested this with incredibly precise atomic clocks. They synchronized two of them, left one at a lower elevation, and flew the other one in an airplane for many hours. When the clocks were brought back together, the one that had been flying high up, in weaker gravity, was slightly ahead of the one that remained on the ground. It had experienced more time. The difference is minuscule, far too small for any human to ever notice. But it is a profound confirmation that the pace of your own time depends on where you are. Every step up a mountain is a tiny journey into a faster flowing future. Your feet are aging just a little bit, slower than your head, because your feet are closer to the center of the earth. than your head is. They are in a slightly stronger gravitational field. The difference is incredibly tiny, almost unimaginably so, but it is there. The river of time is flowing a fraction of a second slower at your feet than it is at the top of your head. Over the course of your entire lifetime, your head will have aged a few nanoseconds more than your feet. It is a gentle, persistent reminder that there is no single you when it comes to time. Every part of your body is experiencing its own unique, local flow of time, dictated by its precise position in the Earth's gravitational field. You are a collection of slightly different timelines, all resting together. The faster you move through space, the slower you move through time. This is the other side of time's malleability, an effect known as time dilation. It is not just gravity that alters the flow of time, but also motion. As you increase your speed through the 3 dimensions of space, your speed through the 1 dimension of time must decrease to compensate. If you were on a spaceship traveling at 99% of the speed of light, your time would slow down dramatically compared to someone on Earth. You might experience only 1 year passing, but when you returned, you would find that 7 years had passed for everyone you left behind. Your clock, your heartbeat, your thoughts, everything about your personal experience of time would be moving in slow motion relative to the rest of the world. A journey through space is always a trade for a journey through time. For a photon of light, time does not pass at all. This is one of the most wondrous and strange ideas in all of physics. A photon, a single particle of light, travels at the ultimate cosmic speed limit. Because of this, from the photon's own perspective, time comes to a complete standstill. A photon that was born in the heart of a star 1 million years ago and traveled across the vast emptiness of space to reach your eye tonight has not aged a single instant. For that photon, its creation and its absorption were the same moment. It experienced its entire journey, 1 million years of our time, as an instantaneous leap. The beginning and the end of its voyage were one. It is a truly timeless traveler, a messenger that does not experience the message's delivery time. Light is a thread that connects 2 moments as if they were one. If you traveled near the speed of light for a year, you could return to an Earth centuries in the future. Let us imagine a journey to a nearby star. You travel in a futuristic spacecraft that can accelerate to 99.99% the speed of light. For you and everyone on board, the journey out and back takes perhaps 2 years of ship time. You watch 2 years worth of movies, eat 2 years worth of meals, and age by 2 years. But because of the incredible slowing of time at such high speeds, on Earth, the clocks have been ticking much, much faster. When you finally return and land, you would find that over 140 years had passed. The world you left behind would be gone, replaced by a future you could only have read about in books. You would have become a time traveler, propelled into the future by the simple act of moving very, very fast. Speed is a quiet, hidden doorway to the future. Time can stretch and shrink like a ribbon of light. It is helpful to let go of the idea of time as a rigid, unbending ruler. It is much more like a soft, elastic ribbon. For someone at rest on Earth, a second is a certain length of this ribbon. But for an astronaut flying past at high speed, that same second of Earth time would appear stretched out, lasting longer from their perspective. And from the Earth's point of view, the astronaut's seconds would appear compressed and shorter. The ribbon of time is constantly being stretched and shrunk depending on your motion and your location in a gravitational field. It is a fluid, dynamic quality of the universe, not a fixed background measurement. Its flexibility is woven into the very nature of reality. Every moment has its own private, flexible length. The now you are experiencing is not the same now for someone on a distant star. We have a powerful intuition that there is a single, universal present moment that all beings in the universe share simultaneously. But relativity shows us this cannot be true. Because the speed of light is finite, it takes time for information to travel. Imagine a civilization on a planet orbiting Proxima Centauri, our nearest stellar neighbor, about 4 light-years away. The now over there that is happening at the same time as your now is something we can never truly know. By the time we could receive any signal from them, 4 years will have passed. What we see of them is always their past. The idea of a simultaneous cosmic now is impossible to define because there is no way to agree on what time it is everywhere at once. The universe is a collection of local nows, like islands in an ocean of time. There is no single, universal clock ticking for the entire cosmos. If you could place perfect clocks on every planet, in every galaxy, you would find that they all tick at different rates. A clock near a supermassive black hole would be ticking incredibly slowly. A clock in the empty void between galaxies would be ticking very fast. A clock on a planet moving at high speed would tick slower than one on a planet moving slowly. There is no master clock, no central pacemaker for the universe. Time is profoundly local. The only time that you can truly measure and know is your own proper time, the time that is passing for you, right here, right now. It is your personal, unique experience of the flow of the cosmic river. Each of us carries our own personal clock through the universe. Every galaxy, every star, and every person experiences its own unique flow of time. This is the beautiful and democratic consequence of time being relative. There is no privileged observer in the universe. No single frame of reference is more correct than any other. An alien in a distant galaxy moving at a different speed and living in a different gravitational field would measure time and space differently than we do. They might see events that we see as happening one after another as happening at the same time. They might measure the length of our galaxy to be shorter than we do. And yet, all of their laws of physics would be just as valid as ours. The universe presents a slightly different face to every observer, yet the underlying rules are the same for all. Reality is a mosaic of countless different, equally valid points of view. The powerful gravity of a black hole slows time down to an almost complete stop. As you approach the event horizon of a black hole, the one-way door, the curvature of space-time becomes extreme. The river of time slows to a crawl. If a friend were watching you from a safe distance through a powerful telescope, they would see you appear to move in slower and slower motion as you got closer. Your movements would seem to take an eternity. They would see your clock ticking more and more slowly until, as you reached the horizon, it would appear to stop altogether. From their perspective, it would take an infinite amount of time for you to cross that boundary. For you, however, your own time would feel perfectly normal as you fell across the edge into the unknown. A black hole is a place where time, from an outside perspective, stands still. Astronauts in orbit age a fraction of a second slower than we do on the ground. An astronaut on the International Space Station experiences 2 competing effects of relativity. On one hand, they are in a slightly weaker gravitational field than we are, which should make their time speed up. On the other hand, they are traveling at over 17,000 miles per hour, which should make their time slow down. It turns out that the effect of their high speed is much more significant than the effect of the lower gravity. The net result is that time for them passes just a little bit more slowly. After a 6-month mission, an astronaut returns to Earth having aged about 0.07 seconds less than the rest of us. It's a tiny time machine carrying them a whisper into our future. Every orbit is a small step out of sync with the world below. GPS satellites orbiting Earth must constantly adjust their clocks to account for time flowing faster for them. This is where the theory of relativity becomes an essential part of our everyday lives. The satellites that make up the global positioning system orbit high above the Earth. Up there, gravity is weaker, so their internal atomic clocks tick slightly faster than clocks on the ground. At the same time, they are moving at high speed, which makes their clocks tick slightly slower. The effect of weaker gravity is stronger in this case. The result is that their clocks gain about 38 microseconds every single day. If engineers did not build corrections for this relativistic effect into the system, the GPS would fail. The tiny errors in time would accumulate, causing navigational errors that would grow by miles every day. Our modern world relies on understanding the gentle ebbs and flows of time. Your lifetime is not a fixed duration, but a journey whose pace can change. We think of a lifetime as a set number of years, a quantity of time. But it is more accurately a distance traveled through the dimension of time. And just like a journey through space, the speed of that journey can vary. While the effects in our daily lives are too small to perceive, it is a fundamental truth that the amount of world time you experience depends on the path you take. Every airplane flight, every trip up a tall building slightly alters the rate at which you travel through time compared to someone who stays still. Your personal world line has its own unique length, its own private duration, shaped by your every movement and your location on the planet. Your life is measured not by a clock on the wall, but by the clock you carry within. The past, present and future might all exist at once, like different points along a river. This is a philosophical interpretation of relativity, but a powerful one. Because the present moment is not universal, it suggests that what is future for you could be past for an observer moving in a different way. This has led some physicists to imagine a block universe where all of time, every moment that has ever been and ever will be, exists eternally and simultaneously. Time doesn't flow in this view, it just is. Our consciousness simply moves through it, illuminating one moment at a time, creating the illusion of passage. The past is not gone and the future is not unwritten. They are just other places in the landscape of space-time that we have not yet reached or have already left behind. All of history might be a silent, unchanging map. Simultaneity is relative. Two events happening at the same time for you could happen at different times for someone else. Imagine you are standing in the exact middle of a moving train car. At the very same moment, lightning strikes the front and the back of the car. Because you are in the middle, the light from both strikes reaches your eyes at the same time, and you correctly say the strikes were simultaneous. Now, imagine someone standing on the ground, watching the train go by. From their perspective, the train is moving forward. The light from the back strike has to travel further to catch up to them, while the light from the front strike has less distance to cover. They would therefore see the front strike first and the back strike second. For them, the events were not simultaneous. Who is right? You both are. There is no single truth about the timing of events in the universe. A muon, a tiny particle from space, should decay before it reaches the ground, but time slows for it, allowing its journey. Muons are unstable particles created high up in Earth's atmosphere when cosmic rays strike air molecules. They have a very short lifespan, only about 2.2 microseconds. Even traveling at nearly the speed of light, this is not enough time for them to reach the surface of the Earth before they decay. And yet we detect them on the ground all the time. The reason is time dilation. Because the muons are traveling so incredibly fast, their internal clocks slow down dramatically from our perspective. A journey that seems too long for their short lifespan in our frame of reference becomes a manageable trip in theirs. Their time has been stretched, allowing them to complete the journey before they vanish. They are tiny, fleeting time travelers born in the upper sky. Time is not just a measurement, it is a dimension you can move through. We are so used to moving freely in the three dimensions of space. We can go forward or backward, left or right, up or down. Our movement through time feels different, as if we are stuck on a conveyor belt that only moves forward. But relativity treats time as a full-fledged dimension, just like the others. While we may not have the technology to move freely within it, to go backward or to jump ahead, it is still a path, a direction, a part of the fundamental landscape. Every object in the universe is on a trajectory through this four-dimensional space. Our inability to control our motion in time doesn't make it any less of a real dimension. It is the fourth road on which all things travel, the rate at which you experience. Time is woven together with your motion through space. Think of your total motion through space-time as a fixed quantity. You can spend this motion budget however you like. If you stay very still in space, as you are now, you can spend almost all of it on moving through time. This is the fastest that time can possibly flow for you. If you start to move through space, you have to divert some of your motion budget from the time dimension to the space dimensions. The faster you move through space, the more you divert, and the slower your passage through time becomes. If you could ever reach the speed of light, you would be spending your entire budget on moving through space, leaving nothing left for moving through time. At that point, your time would stop completely. Your journey is a constant, gentle balance between space and time. A ticking clock is not measuring a universal beat, but its own local rhythm. A clock is a device for counting repetitions of a regular, predictable physical process, the swing of a pendulum, the vibration of a quartz crystal, the oscillation of a cesium atom. But relativity tells us that the rate of all physical processes, including these, is affected by gravity and motion. This means a clock is not tapping into some external universal river of time. It is simply reporting on the rate at which time is flowing in its immediate vicinity. It is measuring its own proper time. So when an atomic clock on a GPS satellite ticks faster, it is because all physical processes, including its atomic oscillations, are genuinely happening faster in that location. Every clock tells its own true, local story. If you could sit on the edge of a black hole for an hour, 1,000 years might pass for the universe outside. This is the ultimate expression of gravitational time dilation. The gravity just outside the event horizon of a black hole is so immense that the flow of time is slowed to a mere trickle compared to the rest of the cosmos. Let's imagine a brave explorer who travels to a supermassive black hole and enters a stable orbit very close to its edge. They spend 1 hour there according to their own clock and their own experience. Then they fire their rockets and travel back to Earth. Upon their return, they would find that centuries or even millennia had passed for humanity. Their 1 hour rest would have been a journey deep into the distant future of the civilization they left behind. The edge of a black hole is the shore of the slowest river in the universe. The history of the universe is not one single story, but a collection of countless local timelines. Because time flows differently for every object depending on its history of motion and its gravitational environment, there is no single, authoritative timeline of cosmic events. The 13.8 billion years that we measure as the age of the universe is the proper time for an observer at rest in the average gravitational field of the cosmos. But for an object that has spent most of its existence near a massive galaxy, less time will have passed. For a photon born in the early universe, no time has passed at all. The universe is a library containing an infinite number of books, each telling the story of history from a different temporal perspective, and each one is equally true. There are as many histories as there are travelers. What we perceive as the passage of time is our movement through the fourth dimension. The feeling that time is flowing past us may be an illusion created by our consciousness. If the block universe view is correct, then all of space-time already exists. The past is not gone and the future is not yet to be. They are just different locations in the four-dimensional map. Our feeling of now is like a spotlight moving along this map, illuminating one moment after another in a steady sequence. We can't see the whole map, only the single spot where our consciousness currently resides. This movement of our awareness creates the powerful and persistent sensation of time passing, of a future becoming the present and then fading into the past. Our now is a gentle spotlight on the vast landscape of eternity. A twin who travels to the stars will return younger than the twin who stayed on Earth. This is the famous twin paradox, a thought experiment, that makes the consequences of time dilation very clear. Imagine two identical twins. One stays on Earth while the other embarks on a long, fast journey to a distant star and back. For the traveling twin, their clock ticks more slowly due to their high speed. When they return to Earth, they will have aged less than the twin who remained behind. The stay-at-home twin might be 80 years old, while the traveling twin is only 40. This isn't a paradox, but a real consequence of their different paths through space-time. The traveling twins' world line was a different length than the earthbound twins, resulting in a different amount of time experienced. Two different paths through space-time can lead to two different ages. Heavy objects create deep, slow-moving pools in the river of time. Let us return to the image of time as a great river. In this river, a massive object like the sun or a neutron star is like a deep hole in the riverbed. The water of time that flows over this hole slows down, lingering in the depression before moving on. The more massive and dense the object, the deeper the hole and the slower the current becomes. A planet like Earth creates a gentler depression where the slowing is barely noticeable. The empty space between stars is like the wide, flat, fast-flowing plains of the river. The universe is a dynamic riverbed, with countless currents and eddies, all flowing at their own pace. And we are simply drifting along in one of its gentler streams. We are floating in a quiet, calm tributary of the cosmic river. The idea of a universal present is just an illusion of our perspective. Our brains are wired to experience reality as a sequence of present moments. This makes perfect sense for survival on a planet where things move very slowly compared to the speed of light. On this scale, we can pretend that now is the same for everyone in the room, or even in the same city. The light travel time is so short that the delay is imperceptible. But as soon as we start thinking on cosmic scales, this comfortable illusion breaks down. There is no way to establish a shared now with someone in another galaxy. The present is not a thin line across the whole universe, but a thick, fuzzy region. Different for every observer, our sense of a shared present is a comfortable, local fiction. The universe doesn't have a single now, but an ocean of them. Instead of a single line of the present, imagine that every event in space-time has its own light cone. This cone represents all the possible future paths that can be influenced by that event, and all the past events that could have influenced it. Your now is a unique slice through this complex, overlapping web of light cones. It is your personal reality constructed from all the light that is just reaching you in this moment from the past. Someone else, even someone standing next to you, but moving differently, will have a slightly different slice, a slightly different now. The universe is an infinite ocean of these possible moments, and we each sail our own unique course through it. Reality is a personal collection of light from the past. The slowing of time is not a mechanical trick. It is a fundamental property of the universe itself. It is easy to think of time dilation as something happening to a clock, as if the clock's mechanism is being physically affected by speed or gravity. But that is not the case. Time itself is slowing down. All processes are affected equally. The vibrations of atoms, the chemical reactions in a battery, the firing of neurons in the brain, the beating of a heart. Everything slows down in perfect unison. A person experiencing time dilation would not feel anything different. Their thoughts would not feel sluggish. Their heart would not feel slow. To them, everything would seem perfectly normal. It is only by comparing their clock to a clock in a different frame of reference that the difference would be revealed. Time itself is breathing at a different rate. A memory is a postcard from a place you once visited in space-time. Every memory you hold is a record of an event that happened at a specific set of four-dimensional coordinates, a particular place at a particular time. In the block universe model, that point in space-time still exists. It is not gone or erased. It is simply in your past. Your memory is a neurological echo of your consciousness, passing through that location on the cosmic map. It is a souvenir from a country you can no longer visit, a postcard from a past self. The collection of all your memories forms the story of your world line, the path your awareness has traced through the grand, silent sculpture of reality. Your mind is a gallery of moments. Collected along your journey, time is a gentle, flowing dimension. Perhaps the best way to rest with these ideas is to let go of our rigid, human-scale intuitions. Instead of a ticking clock, imagine a soft, flowing current. Instead of a ruler, imagine an elastic thread. Time is not a tyrant marching forward with an iron will. It is a part of the physical world, as responsive and dynamic as space itself. It bends for gravity, it yields to speed. It is the gentle, underlying rhythm that allows for change, for motion, and for the story of the universe to unfold. It is the dimension of becoming, the quiet, persistent unfolding of what is possible. And for now, it is the dimension that carries you softly towards sleep. It is the current on which you are invited to drift. The speed of light in a vacuum is the ultimate speed limit of the universe. In the entire cosmos, there appears to be a fundamental speed limit, a barrier that nothing can surpass. That speed is the speed of light, traveling through the emptiness of space at approximately 186,182 miles per second, or about 300,000 kilometers per second. It is a cosmic constant, a fundamental rule of the road for our universe. It is not just a limit for light itself, but for everything. No object with mass, no information, no causal influence can travel faster than this speed. It is woven into the very relationship between space and time. This ultimate velocity is the highest gear of the universe, and only massless things like photons of light are permitted to use it. It is the universe's most profound and unbreakable law. Nothing with mass can ever reach the speed of light, only approach it. As an object with mass is accelerated closer and closer to the speed of light, something remarkable happens. Its effective mass, its resistance to being pushed further, begins to increase. The closer it gets to the light speed barrier, the more massive it becomes from an outside perspective. To push it even faster requires more and more energy. As it approaches the speed of light, the energy required to go any faster approaches infinity. Since there is not an infinite amount of energy in the universe, it is impossible for any object with mass, a spaceship, a planet, or a single atom, to ever truly reach that final, ultimate speed. It can get tantalizingly close, but it can never cross the finish line. The finish line itself recedes into infinity. The speed of light is the same for you, no matter how fast you are moving. This is the strange and beautiful idea upon which all of special relativity is built. It defies all of our everyday logic. Normally, if you are driving in a car at 50 miles per hour and you turn on your headlights, you would expect the light beam to be moving away from you at the speed of light. But for someone on the sidewalk, they should see it moving at the speed of light plus 50 miles per hour. But this is not what happens. No matter how fast you are moving towards a beam of light or away from it, if you measure its speed, you will always get the exact same number, 186,282 miles per second. It is a constant for all observers. To make this strange fact true, the universe must bend everything else, space, time, and mass, to ensure this one rule is never broken. It is the one fixed point in a flexible and flowing universe. Light does not experience time or distance from our perspective. The journey of a photon of light is a long and epic one. We see it emerge from a star, travel for centuries or millennia across the vast, cold emptiness of space, and finally end its journey in an instant as it strikes a receptor, like the retina of an eye. But from the photon's own point of view, its journey is instantaneous. Because it travels at the absolute speed of light, time for the photon dilates to a complete stop, and space in the direction of its travel contracts to nothing. Its departure and arrival are the same event. It crosses a galaxy wider than 100,000 light-years in what is, for itself, a single moment of no duration. It is a timeless traveler, a particle that exists in a state of pure motion, unbound by the passage of moments that governs our lives. For light, the entire universe is a single point, crossed in no time at all. Starlight can be bent by the gravity of a massive galaxy, like a lens bending light. Imagine holding up the base of a heavy, old-fashioned glass and looking through it at a candle flame on the other side of the room. The thick, curved glass would bend the light from the candle, distorting its image, perhaps even making it appear in several places at once. In the cosmos, a massive galaxy or a cluster of galaxies can do the exact same thing. Its immense gravity creates such a deep and powerful curve in the fabric of space-time that it acts as a natural cosmic lens. When the light from an even more distant object, like a quasar or a young galaxy, passes through this curved region, its path is bent. We on Earth can then see this light, which would have otherwise missed us completely, guided towards our telescopes by gravity's gentle hand. The universe itself provides the lenses to see its most distant secrets. Sometimes, astronomers see multiple images of the same distant quasar, its light split by gravity's lens. The effect of this gravitational lensing can be quite dramatic. If the alignment is just right, with the distant object, the lensing galaxy, and Earth all in a perfect line, the light can be bent in such a way that it creates multiple images of the same object. Astronomers might look into their telescopes and see 2, or even 4, identical quasars arranged in a pattern around a central, massive galaxy. They are not 4 different objects, but 4 different paths that the light from a single object has taken to reach us. Each path has a slightly different length, meaning the light from one image might arrive months or even years before the light from another. It's like seeing echoes of light, all from the same source, arriving at different times. Gravity can turn one star into a constellation of ghosts. A star can act as a cosmic magnifying glass, revealing what lies behind it. This lensing effect can also magnify the light from distant objects, making them appear brighter and allowing us to see things that would otherwise be too faint and far away. Sometimes a single star in our own galaxy will drift in front of a much more distant star. The gravity of the foreground star, though small compared to a galaxy, creates its own tiny curve in space-time. For a brief period, as the alignment becomes perfect, this curve acts as a lens, causing the distant star to brighten dramatically before fading back to its normal state. This phenomenon, called microlensing, is a powerful tool. It has even allowed astronomers to detect planets orbiting the lensing star, as the planet's own tiny gravity adds an extra little flicker to the brightening event. Even a single star can open a small window to a world beyond. You are always seeing the past. As light takes time to travel from an object to your eyes, the speed of light, while immense, is not infinite. This means that every single thing you see is a delayed image. There is a small, imperceptible lag between an event happening and the light from that event reaching you. For things in the same room, this delay is only a few nanoseconds, completely unnoticeable. But as we look further out, the delay becomes profound. The image you see of the moon is from 1.3 seconds in the past. The warm light from the sun is from over 8 minutes ago. If the sun were to suddenly vanish, we wouldn't know about it for 8 minutes. Every glance up at the night sky is an act of time travel. You are not seeing the stars as they are now, but as they were when they sent their light on its long journey. The night sky is a museum of ancient history, with every star an artifact. The light from the sun takes over 8 minutes to reach us here on Earth. Let that thought settle in for a moment. The warmth you feel on your skin on a sunny day is the product of nuclear fusion that happened in the core of the Sun millions of years ago, which then took a long journey to the Sun's surface and then traveled for 8 minutes and 20 seconds to cross the 93 million miles of space to Earth. The very light that allows life to flourish is an echo from the Sun's recent past. It is a constant, flowing stream of history, a gift carried on the wings of photons. When you see a sunrise, you are watching an event that has, from the Sun's perspective, already concluded. We live our lives in the gentle, time-delayed glow of our nearest star. We are all basking in yesterday's sunshine. Looking at the Andromeda Galaxy is like looking 2.5 million years into the past. The Andromeda Galaxy is the most distant object that can typically be seen with the naked eye. It appears as a faint, fuzzy smudge in the autumn sky. That faint smudge of light began its journey long before modern humans walked the Earth. It has been traveling through the cold, dark void between galaxies for 2.5 million years. The photons striking your retina tonight left Andromeda when our distant ancestors were just beginning their own journey on the plains of Africa. What we see is a galactic ghost, a portrait of our nearest major cosmic neighbor as it was in a deep and ancient past. We can have no knowledge of what is happening in the Andromeda Galaxy now. We can only wait for another 2.5 million years for that news to arrive. Every photon from deep space is a time capsule. Gravity can change the color of light, stretching it into a deeper red. Light can be thought of as a wave with peaks and troughs. The color of the light depends on the distance between these peaks, its wavelength. As a beam of light climbs out of a deep gravitational well, it has to expend energy to escape. This loss of energy doesn't make the light slow down. It always travels at the same speed, but it does make the light wave stretch out. The distance between the peaks gets longer. This stretching shifts the light towards the red end of the spectrum, a phenomenon called gravitational redshift. Light that falls into a gravitational field experiences the opposite effect, gaining energy and shifting towards the blue. So a star would appear ever so slightly redder to an observer high above it, and slightly bluer to someone deep within its atmosphere. Gravity gently repaints the light that passes through it. Light always follows the straightest possible path, but space-time itself can be curved. A beam of light is the universe's ultimate straight edge. It will always take the most direct route possible from one point to another. So when we see the light from a distant star bending as it passes the Sun, it is not because the light itself is choosing to curve. It is because the very definition of a straight line has been altered by the Sun's gravity. The light is still moving as straight as it possibly can, but it is doing so on a surface that is no longer flat. It is like drawing a perfectly straight line on a curved piece of paper. The line itself is straight, but its projection onto a flat background will appear curved. Light is simply revealing the true underlying geometry of the universe. Light is an honest messenger, faithfully reporting the shape of the road. The path of a beam of light is a map of the curves in space-time. Because light is such a faithful traveler, following the contours of space-time with perfect precision, it becomes our greatest tool for mapping the invisible. By observing how the images of distant galaxies are distorted and warped, astronomers can reconstruct the shape of the space-time between us and them. They can map the locations of vast, unseen clumps of dark matter, whose gravity is responsible for most of the lensing effect. It is a form of cosmic cartography, using the light from the most ancient objects in the universe as the ink to draw a map of the hidden structures that dominate the cosmos. We are learning to read the gentle bends in starlight as if they were contour. Lines on a map of reality, the universe draws its own self-portrait in bent and shimmering light. This cosmic speed limit is what holds the law of cause and effect together. The fact that nothing can travel faster than Light is not just a frustrating limitation. It is the essential glue of a logical universe. It ensures that an effect can never happen before its cause. Imagine if you could send a signal faster than light. You could send a message back in time, telling yourself the result of a race before it begins, and then choose to bet differently, creating a paradox. The universal speed limit of light protects the timeline. It defines a clear boundary between the past and the future for any given event. It means the universe unfolds in a coherent, orderly fashion, where the past influences the present and the present influences the future. In a one-way flow of causality, the speed of light is the gentle guardian of reason. The starlight you see tonight has been traveling through the quiet void for thousands of years. Consider a star in the constellation Orion, perhaps Rigel, a brilliant blue-white supergiant. It is about 860 light-years away. The light that graces your eye tonight from Rigel began its journey around the year 1165. It has been traveling across space ever since, through all the intervening centuries of human history. That light is older than the great cathedrals of Europe, older than the voyages of Columbus. For all those hundreds of years, it has been silently and faithfully crossing the immense distance, a solitary messenger on a vast and lonely road. And tonight, at the very end of its 860-year-long journey, it finds its final destination with you. All the stars in the sky tell a similar story of patient, ancient travel. You are the quiet destination of a 1,000-year journey. Even though it is made of waves, light also behaves like a stream of tiny particles. This is one of the deep and beautiful mysteries of the quantum world. In some experiments, light behaves exactly like a wave, spreading out, interfering with itself and bending around corners, just like a ripple in a pond. But in other experiments, it behaves like a stream of tiny, discrete packets of energy called photons. It arrives in distinct little lumps, not as a continuous flow. It is both things at once, a wave and a particle. It is not that it switches back and forth, but that its true nature is something more profound, something that can show a wave-like face or a particle-like face, depending on the question we ask of it. This wave-particle duality applies not just to light, but to all things, including the atoms in your own body. Everything in the universe is both a ripple and a fleck of dust. The speed of light is not just a speed. It is the rate at which causality itself can travel. Think of it as the speed of information. If a distant star explodes, the absolute fastest that the news of that event can reach us is the speed of light. Nothing can outrun it. The explosion creates gravitational waves which travel at the speed of light. It creates neutrinos which travel at nearly the speed of light. And it creates photons which travel at the speed of light. Before those messengers arrive, that event for us is in the future. It has no ability to affect us. The speed of light is the conversion factor between space and time, the fundamental number that determines how quickly a change in one part of the universe can be felt in another. It is the speed at which one moment can speak to the next. An Einstein cross is when a single distant object appears as four, its light perfectly bent around a galaxy, sometimes the alignment of a distant quasar, a lensing galaxy. And our own planet is so perfect that a particularly beautiful illusion is created. The gravity of the foreground galaxy splits the light of the quasar into four distinct images arranged in a cross-like pattern around the galaxy's core. It looks like four separate objects, but spectroscopic analysis reveals that all four have the identical signature of the same single quasar. It is a stunning and rare piece of cosmic artistry, a perfect demonstration of space-time being warped by mass. Seeing an Einstein cross is like finding a four-leaf clover in the fields of the night sky, a sign of a special and precise alignment across billions of light years. It is a cosmic jewel, faceted by the gravity of an entire galaxy. Light that falls into a black hole will never emerge again. A black hole is defined by its event horizon, a boundary in space-time from which nothing, not even light, can escape. Any beam of light that crosses this boundary is trapped forever. Its journey comes to an end inside the black hole's singularity. This is because inside the event horizon, the curvature of space-time is so extreme that all possible paths, all geodesics, lead only inward toward the center. For a photon of light inside a black hole, every direction it could possibly travel in is a direction that takes it deeper inside. The future itself points only one way, toward the singularity. It is the one place in the universe where the cosmic speed limit is not enough to allow for an escape. It is a place where all roads lead to the center. The constant speed of light is the bedrock upon which all of relativity is built. Einstein began his journey by asking a simple, profound question: what would happen if you could ride alongside a beam of light? He realized that if you could, the light wave would appear to be stationary, a frozen wave of electric and magnetic fields. But this contradicted the known laws of electromagnetism. He concluded that it must be impossible to catch up to a beam of light. Its speed must be absolute, the same for everyone. From this one simple-sounding postulate, all the strange and wondrous consequences of special relativity flow: the slowing of time, the contraction of length, the equivalence of mass and energy. Everything else in the universe must be flexible, so that this one thing, the speed of light, can remain rigid and constant for all. It is the firm anchor in a sea of cosmic relativity. Light carries information about the shape of the universe it has traveled through. A photon of light is like a tiny witness. On its long journey from a distant galaxy to your eye, it is subtly affected by everything it passes. The expansion of the universe stretches its wavelength, making it redder. The gravitational pull of galaxy clusters bends its path. Clouds of interstellar dust can absorb and scatter it, changing its color and intensity. By carefully studying the light that reaches us from the early universe, scientists can read the story of its journey. They can learn about the distribution of matter, the rate of cosmic expansion, and the composition of the things it passed through. The light itself becomes a fossil record of the universe's history and structure. Every photon is a historian, carrying a story in its color and path. If you could travel at light speed, every destination would be instantaneous. Let us return to the strange perspective of a photon. For an object with mass, reaching the speed of light is impossible. But if we could imagine it, what would such a journey be like? At that ultimate speed, time dilation would become infinite. Your own clock would completely stop, and length contraction in the direction of your travel would also become infinite. The entire universe, from your starting point to your destination, would shrink to a single point of zero length. The trip would be over at the exact same instant it began. You would be everywhere along your path at once. It is a state of being that is difficult to wrap our minds around. A timeless, distanceless existence at light speed. The journey and the arrival are one and the same. A star doesn't have to be directly in our line of sight for us to see it. If something massive bends its light toward us, normally, if a large dark object floated between you and a distant star, it would block your view. But in the universe of curved space-time, this is not always the case. If the intervening object is massive enough, like a star or a black hole, it can bend the light from the star behind it around its own edges. The light that would have gone off in other directions is refocused and sent towards you. This means you could see a star even when it is technically eclipsed by another object. The gravity of the foreground object acts like a lens, allowing you to peek around the corner. It is another way the universe reveals that the straight path is not always the one our simple intuition expects. Gravity is a current that can carry starlight around obstacles. The universe is painted with ancient Light everywhere we look. We are seeing a canvas covered in light of different ages. The light from your lamp is mere nanoseconds old. The light from the moon is just over a second old. The light from the stars is centuries or millennia old. The light from the Andromeda galaxy is millions of years old. And the faintest light we can detect, the cosmic microwave background radiation, is the oldest light of all. It is the afterglow of the Big Bang itself, an echo of creation that has been traveling for 13.8 billion years. The universe is a vast, layered painting of time, and our telescopes are windows that allow us to look down through these layers to the very beginning. To look out into space is to look back through the pages of a cosmic album. Light is a messenger from the past, following the contours of the present. This is the beautiful summary of light's role in a relativistic universe. Every photon that reaches us is a messenger, carrying a story from a past event, the nuclear fusion in a star, the reflection of a planet's surface. That message is ancient, a relic from a time that has passed. But the path the messenger takes is determined by the shape of the universe as it exists right now. It dutifully follows the curves and dips in space-time created by the current distribution of matter and energy. It is a perfect synthesis of past and present. It is a story from long ago told on the landscape of today. It is a timeless traveler on a timely path. Matter is a form of frozen, concentrated energy. We tend to think of matter and energy as two completely different things. Matter is the solid, stable stuff of the world, rocks, trees, our own bodies. Energy is the active, intangible thing that creates change and motion. Light, heat, sound. But Albert Einstein's most famous equation, E=mc2, revealed a deep and shocking truth. They are two faces of the same underlying substance. Matter is simply energy that has been slowed down and packed together into a stable form. It is like the relationship between water and ice. Ice is simply water that has settled into a quiet, solid state. In the same way, matter is energy in a state of rest. Every object you can touch is a piece of slumbering. Frozen light, a single drop of water holds a quiet, hidden storm of atomic energy. The equation E=mc2 tells us exactly how much energy is locked away inside a piece of matter. The E stands for energy, the m for mass, and the c2 is the speed of light squared. Because the speed of light is such an enormous number and it is squared on top of that, the formula tells us that even a tiny amount of mass is equivalent to a staggering amount of energy. The mass contained in a single drop of water, if it could be converted entirely into energy, would be enough to power a large city for a day. This vast, dormant potential rests quietly within every object around you, a silent testament to the immense power bound up in the substance of the world. The universe is far more potent than it appears. The sun shines by converting its own mass directly into light and heat. For centuries, the source of the sun's power was a deep mystery. What could possibly burn so brightly for so long? The answer lies in E=mc2. In the sun's incredibly hot and dense core, under immense pressure, hydrogen atoms are fused together to create helium. This process, called nuclear fusion, is not perfectly efficient. The resulting helium atom has slightly less mass than the hydrogen atoms that went into making it. This tiny amount of missing mass has not vanished. It has been converted directly into a tremendous burst of energy in the form of light and heat. This is the energy that pushes its way out of the sun's core and radiates out into space, warming our planet and making life possible. The sun is slowly dissolving itself into sunshine. Every second, the sun transforms 4 million tons of matter into pure energy. Let that number settle. 4 million tons. Every single second, a mass equivalent to a great mountain is annihilated in the heart of the sun and reborn as the radiant energy that floods our solar system. It is a rate of conversion that is almost impossible to comprehend. And yet the Sun is so immense, so vast, that it has been doing this for 4.5 billion years, and it has enough fuel to continue for another 5 billion more. It is a slow, steady, and colossal act of transformation. The light that warms your face is the ghost of matter that no longer exists, a message from the heart of a star that is constantly sacrificing a tiny part of itself to illuminate its worlds. The sunlight on a leaf is the final form of a vanished piece of a star. Massy is simply a measure of how much energy is contained within an object at rest. This is another way to understand the profound meaning of the equation. We usually think of mass as a measure of how much stuff is in an object or how heavy it is. But a deeper definition is that an object's mass is a measure of its total internal energy content when it is not moving. This includes the energy binding its atoms together, the energy of its moving electrons, and the immense energy locked away in the atomic nuclei themselves. When you try to push an object to make it move faster, its resistance to your push, its inertia, is really its resistance to having its energy changed. Mass and energy are so deeply intertwined that they are, in a very real sense, the same thing. To weigh an object is to measure its slumbering power. The equation E equals mc2 is like a cosmic recipe for turning matter into light. Think of it as the most fundamental recipe in the universe's cookbook. It gives you the precise exchange rate. If you want to know how much energy you can get from a certain amount of mass, this is the formula you use. The universe uses this recipe in the hearts of stars and in the explosive deaths of supernovae. Humans have learned to use it in nuclear reactors and, tragically, in atomic weapons. It is a statement of pure potential, a promise of the incredible energy that is hidden in the quiet stillness of matter. It doesn't tell you how to perform the conversion. That is a much more difficult problem, but it tells you the ultimate reward if you can succeed. It is the secret of starlight. Written in a few simple symbols, the atoms that make up your body contain a vast and dormant power. Consider the carbon, oxygen, and hydrogen atoms that constitute your being. Each one is a tiny, self-contained reservoir of bound energy. The forces that hold the protons and neutrons together in the nucleus of each atom are incredibly strong, and they represent a huge amount of stored energy. If you could take a single gram of the matter in your body and convert it entirely to energy, the release would be more powerful than the largest conventional bombs ever created. It is a humbling thought that this quiet, stable-seeming physical form we inhabit is, at its most fundamental level, a vessel of such immense and unimaginable power, held in a state of perfect, peaceful balance. You are a temporary sculpture made of contained lightning. A tiny amount of mass can be released as a tremendous amount of energy. This is the key to understanding both the power of the stars and the power of nuclear energy. In both fusion in stars and fission in our reactors, the process works by rearranging atomic nuclei into a new configuration that has slightly less mass than the original. It is only a tiny fraction of the total mass, usually less than 1%, that gets converted into energy. But because the C2 term in the equation is so gigantic, even this tiny fraction of mass releases a disproportionately huge amount of energy. It is a testament to the universe's incredible leverage. A small and subtle change at the atomic level can unleash a force that can power a city or create a star. The universe knows how to turn a whisper of mass into a roar of light. This simple equation explains how stars can burn for billions of years. Before Einstein, scientists were puzzled. If the sun were made of something like coal, it would burn out in only a few thousand years. If its heat came from gravitational contraction, it could only last for a few million years. Neither was long enough to account for the age of the Earth and the slow process of evolution. But nuclear fusion, governed by EEMC2, provided the answer. By converting mass into energy, the sun tapped into a fuel source so fantastically efficient that it could sustain its output for the immense timescales required. The equation unlocked the secret to the longevity of the stars, and in doing so, allowed us to understand our own long, slow history. The stars have enough inner substance to burn with a patient, ancient fire. Energy, like light, also has mass and can bend the fabric of space-time. The full equation of general relativity states that it is not just mass that warps space-time, but all forms of energy and momentum. Since matter is just a form of energy, this makes perfect sense. This means that a hot object is actually infinitesimally heavier than the same object when it is cold, because the heat energy within it adds to its total mass energy and therefore to its gravity. A box full of bouncing energetic photons of light would create a slightly stronger gravitational field than an empty box. The effect is far too small to ever measure in these cases, but it points to the deep truth that gravity is a response not just to stuff, but to the presence of energy in any form. Gravity is the universe's response to the presence of anything at all. As an object approaches the speed of light, its mass appears to increase. This is a direct consequence of the mass-energy equivalence. As you put more and more energy into an object to accelerate it, that kinetic energy, the energy of motion, starts to contribute to the object's total mass. From the perspective of a stationary observer, the object becomes heavier and heavier, and therefore harder and harder to accelerate further. This is another way of understanding why you can never reach the speed of light. As you approach it, your mass would approach infinity, and it would take an infinite amount of energy to push you any faster. The energy you are adding to the system is transforming into mass, instead of into more speed. The energy of your motion becomes a part of your being. The universe is a great dance between matter and energy, constantly transforming into one another. On the grandest scale, this is the story of the cosmos. In the fiery heat of the Big Bang, the universe was a sea of pure, undifferentiated energy. As it expanded and cooled, this energy began to condense, to freeze into the first particles of matter. For billions of years since, in the hearts of stars, that matter is slowly and partially being turned back into energy. In the violent explosions of supernovae, new, heavier elements are forged, another transformation. And perhaps in the distant, far future, matter itself will decay, releasing its stored energy back into a quiet and cool universe. It is a vast cyclical ballet of transformation, with EIMC2 as the choreographer. It is a story of becoming, unbecoming, and becoming again. The creation of the universe in the Big Bang was the ultimate conversion of energy into matter. In the very first moments after the Big Bang, the universe was a quark gluon plasma, a soup of fundamental particles and pure energy, so hot and dense that matter as we know it could not exist. As this primordial universe expanded and cooled, it reached a point where the energy could coalesce into the first stable protons and neutrons. This was the Great Freezing, the moment when the radiant energy of creation first took on the familiar substance of matter. All the matter that we see in the universe today, every star, every planet, every living thing is a direct descendant of that first great act of transformation, a relic of the cooling fire of the beginning. Every atom is a fossil from the first second of time. Nuclear power is just the quiet whisper of this immense cosmic principle. When we use nuclear fission in a power plant, we are not creating energy from nothing. We are simply finding a clever way to rearrange the protons and neutrons inside very large atoms, like uranium, into smaller, more stable atoms. In this rearrangement, a tiny fraction of the original mass is converted into heat. We are tapping, in a very small and controlled way, into the same fundamental principle that powers the sun. We are taking advantage of the fact that some configurations of matter are slightly less massive, and therefore more energetically stable than others. It is a quiet, earthly echo of the roaring furnaces inside the stars. We have learned to light a small candle from the fire of the cosmos. A particle and its antiparticle can annihilate each other, turning their entire mass into light. For every particle of matter, there exists a corresponding antiparticle with the same mass but the opposite charge. An electron has a positron, a proton has an antiproton. When a particle and its antiparticle meet, they annihilate each other in a perfect and complete expression of EmC2. Their entire mass, 100% of it, is converted into pure energy, typically in the form of high-energy photons of light called gamma rays. This is the most efficient mass-to-energy conversion possible in the universe. In the early moments of the Big Bang, the universe was full of these particle-antiparticle pairs constantly being created from energy and annihilating back into it. It is the universe's most perfect act of release. The weight of an object is a measure of its energy content. Because mass and energy are equivalent, we can say that anything that has energy has a relativistic form of mass, and therefore is affected by gravity. This leads to a fascinating conclusion. The weight of an object is not just the sum of the mass of its constituent particles, it also includes the energy of the bonds between them and the energy of their internal motions. For example, the protons and neutrons inside an atomic nucleus are moving around at tremendous speeds. The energy of this motion contributes significantly to the total mass of the nucleus. In fact, most of the mass of the everyday objects around you comes not from the particles themselves, but from the energy of their interactions and motion. The world is made mostly of bound-up motion. Even a coiled spring is slightly heavier than a relaxed one because of the energy stored within it. This is a beautiful, everyday example of mass-energy equivalence. When you compress a spring, you are storing potential energy within its structure. That added energy, according to EmC2, must add a tiny amount of mass to the spring. It will therefore be infinitesimally heavier and create an infinitesimally stronger gravitational field. The difference in mass is far too small to ever be measured, smaller than the mass of a single atom. But it is a real and true consequence of the theory. Every form of potential energy, chemical energy in a battery, gravitational potential energy in a raised weight, adds its own small contribution to the total mass of a system. The light from the stars is the echo of mass being transformed. When you look up at the night sky, every single point of light you see from a star is a testament to this principle. You are witnessing the real-time conversion of matter into energy broadcast across light years of space. The starlight is not a byproduct of some other process. It is the process. It is the form that the transformed mass takes. The universe is lit by the glow of mass slowly dissolving into radiance. It is a quiet, gentle, and continuous process on a cosmic scale, a slow exhalation of energy that has been happening for billions of years and will continue for billions more, all across the vast canvas of the night. The stars are lanterns that consume their own substance for fuel. Matter is like a slow, sleeping form of energy. Perhaps the most restful way to think about this relationship is to see matter as energy that has found a quiet place to rest. In the frantic, hot environment of the early universe, energy was too agitated to settle down. But as the universe cooled, some of that energy found a way to bind itself up into the stable, long-lasting patterns we call particles. It went into a kind of hibernation, a deep sleep. But the potential for it to reawaken is always there, slumbering within the heart of every atom. The stars are the places where a small amount of that energy is gently stirred from its slumber and encouraged to wake up as light. Every object around you is a vessel of sleeping fire. Every object is a vessel of slumbering light. Let that be a final, quiet thought on this topic. The The chair you are sitting on, the book on your table, the very air you breathe, all of it is composed of matter that is, in its essence, a form of condensed energy. It is light that has been folded up on itself over and over until it became solid and tangible. The entire physical world in this view is a manifestation of light in a different form. It is a slow, quiet, and stable vibration of the same fundamental essence that streaks across the cosmos at the ultimate speed. The universe found a way for light to build a house and rest for a while, and we call that house matter. The world is made of light that has learned to be still. The collision of two black holes sends silent ripples through the fabric of space itself. Imagine two of the most massive, most compact objects in the universe, two black holes locked in a gravitational dance. They spiral closer and closer together, orbiting each other hundreds of times a second in the final moments. As they do, they violently churn the space-time around them like two massive beaters in a bowl of cosmic dough. This disturbance is not contained. It radiates outward, not as sound or light, but as waves in the very structure of reality. When they finally merge, a single, tremendous burst of these gravitational waves is released. For a fraction of a second, the energy released in this collision is greater than the light from all the stars in the observable universe combined, yet it is all released in perfect silence. It is the most powerful storm in the universe, and it makes no sound. These gravitational waves stretch and squeeze everything they pass through, including you. As these ripples of space-time wash over the Earth, they have a subtle physical effect. They are transverse waves, which means they cause a distortion perpendicular to their direction of travel. As a wave passes through you, it would first stretch you vertically while squeezing you horizontally, and then a moment later, it would stretch you horizontally while squeezing you vertically. The effect is impossibly small for the first gravitational wave ever detected. The amount of stretching and squeezing was 1,000 times smaller than the nucleus of an atom. You would never, ever feel it. But our most sensitive instruments, great L-shaped detectors with lasers bouncing down long tunnels, can detect this infinitesimal cosmic breath. The entire universe gently flexes as these ancient waves pass by. For 1 billion years, these waves traveled across the universe to finally wash over us. The first gravitational wave signal that was successfully detected in 2015 came from a truly ancient and distant event. It was the merger of two black holes that were about 30 times the mass of our Sun. The collision happened in a distant galaxy about 1.3 billion light-years away from us. This means the waves themselves had been traveling through intergalactic space for 3 billion years. When they were created, the most complex life on Earth was just single-celled organisms. The waves have been journeying through space ever since, silently carrying the story of that cataclysmic merger, until they finally washed over our planet and into our detectors, delivering their billion-year-old news. We are feeling the tremors of a storm that happened in the deep past. A black hole is not an object, but a place where space-time is falling inward. We often think of a black hole as a thing, a dark star that sits in space. But a more accurate and wondrous way to imagine it is as a region of space that is itself in motion. Think of a wide, calm river that suddenly narrows and flows over a huge waterfall. The water itself is flowing, and once it passes a certain point, the edge of the falls, it cannot flow back up. A black hole is like this, but with the fabric of space-time itself. The mass of the collapsed star has curved space-time so extremely that it creates an inward-flowing current. The event horizon is the point of no return, where the current of space is flowing inward faster than the speed of light. It is a waterfall made of pure space and time. It doesn't suck things in, it is a region where the current of space flows faster than light. The common image of a black hole as a cosmic vacuum cleaner is misleading. A black hole's gravity is no different from any other object of the same mass, as long as you are far away from it. If you replaced our Sun with a black hole of the exact same mass, the Earth and the other planets would continue to orbit it just as they do now. They would not be suddenly sucked in. The danger of a black hole is only in its immediate vicinity. You have to get very close to the event horizon to be caught in that powerful, one-way current of space-time. It is not an active predator. It is a passive and extreme feature of the cosmic landscape, a place where the river of reality simply flows downhill at an impossible speed. You have to sail over the edge of the falls to be trapped by it. The edge of a black hole is a one-way door in the universe. The event horizon is a truly remarkable concept. It is not a physical surface. You would not bump into it. If you were to fall into a very large black hole, you might not even notice the exact moment you cross the event horizon. There is no signpost, no barrier, but it is an absolute causal boundary. Once you are inside, you cannot send any light or information back out to the universe you left behind. You cannot escape because to do so would require traveling faster than the speed of light against the inward rush of space-time. It is a one-way membrane in the fabric of reality, a door through which you can enter but never leave. It is a silent threshold between the known and the unknowable. At the center of a black hole, our understanding of space and time comes to an end. According to the theory of general relativity, all the matter that falls into a black hole is crushed down into an infinitely small, infinitely dense point at the very center.
This point is called a singularity.
At a singularity, the laws of physics as we currently understand them break down completely. The curvature of space-time becomes infinite. Density becomes infinite. Our concepts of when and where lose their meaning. It is a place where the two great pillars of modern physics, general relativity and quantum mechanics, give conflicting answers. The true nature of the singularity is one of the deepest unsolved mysteries in science, a place where the universe is hiding a secret we have not yet deciphered. It is a point where the language of our physics falls into silence. Time flows so slowly near a massive black hole that the universe outside seems to fast forward. Let us revisit the idea of gravitational time dilation in its most extreme form. For an observer hovering just outside the event horizon of a black hole, time would be passing incredibly slowly. From their vantage point, looking out at the distant stars, they would see the universe in fast forward. They might watch galaxies rotate, stars be born and die, and entire civilizations rise and fall, all in what feels to them like a short afternoon. The deep gravitational well of the black hole is a place of extreme temporal distortion, a bubble of slowness in the cosmic river. It is the closest thing in our universe to a natural time machine for viewing the far future. It is a cosmic balcony with a view of all of future time. We can't see a black hole, but we can see the stars that orbit the emptiness where it sits. Since black holes themselves emit no light, we must find them through their effects on the things around them. One of the most common ways is to watch the motion of stars. At the center of our own Milky Way galaxy, astronomers have spent decades tracking the orbits of a cluster of stars. These stars are moving at incredible speeds, whipping around a single, central point that is completely dark. By measuring their orbits, scientists can calculate that they must be circling an object with a mass of over 4 million suns, all packed into a space smaller than our solar system. The only thing that could possibly be that massive and that dark is a supermassive black hole. We see the invisible dancer by watching the motion of its partners. Supermassive black holes are thought to reside at the heart of nearly every
Large galaxy. It seems to be a
fundamental feature of galaxies, like our own Milky Way. At the very center of the great, swirling disk of stars, there lies a monster. These are not the stellar mass black holes left over from a single collapsed star, but supermassive black holes that are millions or even billions of times the mass of our Sun. How they got to be so large is still a topic of intense research. Perhaps they started as smaller black holes that have been steadily feeding on gas and stars for billions of years, or perhaps they were born from the direct collapse of immense gas clouds in the early universe. Whatever their origin, they appear to be the quiet, gravitational anchors around which the great cities of stars are built. They are the still, silent hearts of the great cosmic hurricanes of stars. The sound of two black holes merging is a quiet chirp in the symphony of space-time. When we convert the signal of a gravitational wave into an audible sound, it has a distinct and beautiful character. As the two black holes spiral closer and closer, they orbit faster and faster. This causes the frequency of the gravitational waves they emit to increase and their amplitude to grow. The resulting sound starts as a low rumble and then rapidly rises in pitch and volume over the course of a few seconds, ending in a final sharp chirp at the moment of merger. It is a sound that has been traveling for 1 billion years, a sound made by the flexing of space-time itself. It is the universe's own unique voice, and we are just now learning how to hear its strange and wonderful music. It is the sound of a silent storm, finally reaching shore, of course. Let us begin the final part of our journey. The current of our exploration is slowing now, becoming wider and more peaceful as it nears the great quiet ocean of sleep. Settle back into that feeling of gentle, weightless drifting. Here is the third and final section of the script. It contains the remaining hypnotic nuggets and the concluding outro, designed to gently deliver you to a night of deep and restful sleep. These waves are not traveling through space. They are a disturbance of space. This is a subtle but profound distinction. When sound travels, it is a pressure wave moving through a medium like air or water. When light travels, it is an electromagnetic wave moving through space-time. But a gravitational wave is different. It has no medium. It is the medium itself that is waving. The very fabric of distance is oscillating. As the wave passes, the distance between two free-floating points in space will rhythmically increase and decrease.
It is the geometry of the universe itself that is ringing like a bell, a vibration of the stage on which all reality plays out.
It is the most fundamental kind of disturbance possible in the cosmos. Space itself is singing a deep and silent song. Listening to gravitational waves is like listening to the silent echoes of creation. For all of human history, our knowledge of the universe has come from studying light. We have used our eyes and then telescopes to look at the electromagnetic radiation coming from stars and galaxies. But this is like experiencing the world using only one sense. Gravitational waves have opened up a completely new way to perceive the cosmos. We are no longer just looking at the universe.
We are listening to it.
We are listening to the vibrations caused by its most hidden and violent events, the collision of black holes, the merging of neutron stars. It is a new sense, allowing us to perceive the dark, silent side of the universe that emits no light at all. We have grown. A new ear to hear the whispers of the void. Einstein imagined these
waves a century before we were able to detect
them. 100 years before the LIGO detectors felt that first, faint tremor from a distant black hole merger. Albert Einstein, working with only a pen, paper, and his own profound intuition, predicted that these waves must exist. His theory of general relativity, his new description of gravity, implied that massive, accelerating objects would create these ripples in the fabric of space-time. For a century, they remained a beautiful but unproven theoretical consequence. The waves were thought to be so incredibly faint, so impossibly difficult to detect, that many doubted we ever would. The eventual detection was a monumental triumph, a testament to human ingenuity and the incredible, predictive power of a beautiful idea. He heard the silent music of the cosmos, long before we had built the instrument to play it. They are a new way to observe the universe without using light at all. This new sense of cosmic listening is so powerful because gravitational waves can travel through things that would block light completely. They pass through vast clouds of interstellar dust, through the hearts of stars, through entire galaxies, completely unimpeded. This means we can use them to see into the hearts of the most extreme and obscured events. We can witness the exact moment two neutron stars collide to forge heavy elements like gold and platinum. We can observe the merger of black holes in the crowded centers of ancient galaxies. We might even one day detect the faint, primordial gravitational waves from the Big Bang itself, a faint echo of the first instant of time. It is a way of seeing the universe with our eyes closed. The universe has a quiet, invisible weather made of these space-time ripples. Just as the Earth's atmosphere is constantly filled with winds and pressure fronts, the fabric of space-time is constantly being crisscrossed by a faint storm of gravitational waves from countless sources all across the universe. Most are too faint for us to detect individually, but together they create a constant, quiet background hum. It is the combined chorus of every pair of orbiting stars, every spinning neutron star with a slight imperfection, every distant collision of black holes. The universe is never truly still. It is always shimmering with this faint, residual vibration, a quiet and persistent weather pattern on the ocean of space-time. The cosmos is alive with a silent, invisible turbulence. A wormhole is a theoretical bridge or tunnel through the fabric of space-time. Within the beautiful mathematics of general relativity, there exist intriguing and speculative solutions. One of these is the concept of an Einstein-Rosen bridge, which has come to be known as a wormhole. It is a hypothetical shortcut, a tunnel that could connect two very distant points in space or even two different moments in time. Imagine taking a large sheet of paper marking two distant points and then folding the paper over so the 2 points touch. A wormhole is the theoretical, three-dimensional equivalent of punching a hole through that fold, creating a path that is much shorter than traveling the long way around on the surface. It is a gentle fold in the map of reality. It is a hypothetical shortcut connecting two distant points in the
universe. The idea is a tantalizing one.
A journey that might take thousands of years traveling through normal space could, in principle, be completed in a very short time by passing through a wormhole. You could step through a doorway on Earth and emerge moments later in a different galaxy, or you could step through and emerge in the same place, but at a different time. It is a concept that has captured the imagination, a possibility written in the language of physics that speaks of a universe that might be far more interconnected, with more hidden pathways and secret doors than we can currently perceive. The universe may contain hidden passages in its folds. The equations of relativity
Allow for the possibility of these cosmic tunnels.
It is important to remember that while the mathematics of relativity permits wormholes to exist, we have never seen one, and we have no evidence that they are a real feature of our universe. The equations that describe them also suggest they would be incredibly unstable. Most known types of wormholes would collapse in on themselves the instant anything tried to pass through them. To hold one open might require a form of exotic matter with strange properties like negative energy or negative mass, which may not exist in nature. For now, they remain a beautiful and fascinating possibility, a ghost that haunts the elegant equations of space-time. They are a dream the universe is having, written in the language of mathematics. A journey through a wormhole could be a journey through space, time, or both. Because space and time are so deeply intertwined, a tunnel through space-time could connect not just different places but different times as well. A wormhole could, in theory, connect the present day with a moment 1,000 years in the future or 1,000 years in the past. This, of course, raises all sorts of paradoxes about causality and changing the past. This is another reason many physicists believe that some unknown principle of nature must prevent such things from forming. But their possibility reminds us that the landscape of space-time, as described by relativity, is a rich and mysterious place, with features that still challenge the very limits of our understanding and imagination. It is a whisper of the possibility of touching the past or the future. They remain a beautiful mathematical possibility, a what-if written in the stars. It is perhaps best to think of wormholes not as a likely mode of future travel, but as a deep and insightful question that the universe is asking us. They push our understanding of physics to its absolute edge. By studying the properties of these theoretical objects, scientists learn more about the fundamental nature of gravity, causality, and the structure of reality itself. They are a valuable tool for thought, a way of exploring the most extreme and unusual shapes that space-time could possibly take. Whether or not they are real, they are a source of wonder, a sign that the universe described by our theories is a strange and magical place. They are a poem written in the language of physics. Like a fold in a piece of paper, a wormhole connects 2 points with a gentle curve. The geometry of a wormhole is one of profound and elegant curvature. It is not a violent tearing of the cosmic fabric, but a smooth, continuous shaping of it. Imagine 2 funnel shapes joined together at their narrowest points. This is what simple wormhole might look like if you could see it from the outside. You would enter the wide mouth of one funnel, travel through the narrow throat in the middle, and emerge from the mouth of the other funnel in a different part of the cosmos. The journey through the throat would be the shortcut. It is a beautiful sculptural solution to the equations, a piece of cosmic architecture designed by the laws of gravity. It is a gentle archway across the vastness of space-time. A spinning star can drag the very fabric of space-time around with it, like a spoon stirring honey. Let us return to a real and measured effect. When a massive object spins, it doesn't just sit in a static space-time dip. Its rotation actively twists the space-time in its immediate vicinity. The effect is called frame dragging. Space-time itself is pulled into a gentle, swirling vortex around the spinning object. It means that the very concept of being stationary is altered. If you were to place a gyroscope in orbit around the Earth, you would expect its axis to always point in the same direction relative to the distant stars. But because of frame dragging, the Earth's rotation ever so slightly drags the gyroscope's orientation around with it. The rotation of the Earth stirs the reality in its neighborhood. This effect, called frame dragging, has been measured by satellites orbiting Earth. This is not just a theoretical idea. In 2004, a NASA mission called Gravity Probe B was launched to measure this precise effect. The satellite contained 4 of the most perfect spheres ever created by humanity, spinning as gyroscopes in a vacuum. After a year in polar orbit, scientists were able to measure the tiny, predicted shift in the orientation of these gyroscopes. The amount of twisting was minuscule, a change of only 39 milliarcseconds over the year, but it perfectly matched the predictions of Einstein's theory. It was a beautiful confirmation that space-time is not a passive stage, but a dynamic, viscous-like fluid that can be stirred and dragged by the objects within it. We have felt the ghost of the Earth's rotation, pulling on the world. Your sense of straight ahead is slightly different because the Earth is spinning. The space through which you are moving right now, at this very moment, is being gently twisted by the rotation of our planet. This means that the straightest path for a free-floating object near the Earth is not a simple orbit, but one that is slightly dragged along by this cosmic whirlpool. The effect is far too small for us to ever perceive in our daily lives, which are dominated by friction and other forces. But it is a constant and gentle background presence. It is a quiet reminder that we live within the gravitational sphere of influence of a large, spinning ball. and its motion is impressed upon the very geometry of the space we inhabit. Our planet's spin is subtly written into the shape of our now. The universe is filled with these subtle, ghost-like effects of gravity. General relativity is not just about the grand and obvious effects, like the orbits of planets or the formation of black holes. It is also a theory of incredibly subtle and delicate phenomena. It predicts the tiny shifts in starlight, the minuscule slowing of clocks, the almost imperceptible dragging of space. It is in these small, precise predictions, which have now been confirmed by experiment after experiment, that the true power and beauty of the theory reside. It paints a picture of a universe that is deeply interconnected, where every motion and every bit of mass has a subtle but real influence on the entire structure of reality, in ways we are only just beginning to fully appreciate. The cosmos is a place of faint whispers and gentle nudges. A white hole is the theoretical opposite of a black hole, a place where things can only exit. Just as the mathematics of relativity describes black holes from which nothing can escape, it also allows for their perfect time-reversed opposite, white holes. A white hole would be a region of space-time from which things can escape, but into which nothing can enter. It would be a source that spews out matter and energy, but is causally disconnected from its past. You cannot trace a path back into it. Like wormholes, there is no evidence that white holes exist in our universe. They may be a purely mathematical curiosity. Some have speculated that the Big Bang itself might have been something like a white hole,
a singular event from which everything in our universe
emerged. It is a hypothetical fountain at the heart of the cosmos. The universe, described by relativity, is far stranger and more wonderful than we can imagine. As we wander through these ideas of time that flows at different rates,
of space that can bend and ripple and twist, of matter that is frozen energy,
of gateways to other times and places, it becomes clear that the reality we inhabit is a place of profound mystery and wonder. The world of our everyday intuition, with its solid objects and steady flow of time, is just a simplified sliver of the whole picture. The underlying reality is a dynamic, fluid, and magical seeming place that continues to surprise and delight us the deeper we look. It is a universe that is not only stranger than we imagine, but stranger than we can imagine. It is a great, unsolved poem, and we are just learning the alphabet. These cosmic whispers tell us the story of the universe's most silent, powerful events. The faint, almost undetectable signals that we have been exploring, the bending of starlight, the ripples of gravitational waves, the tiny shifts in clocks are our only way of learning about the deepest workings of the cosmos. They are the clues left behind by the universe's most private and powerful moments. They are the whispers that tell the story of gravity's true nature. By learning to detect and interpret these faint messages, we are piecing together a new and more profound story of our universe. A story that is written not in bright lights, but in the subtle geometry of a silent, invisible world. We are learning to read the secret language of space-time. We are just learning to listen to the rhythm of space-time itself. Our journey into gravitational wave astronomy is just beginning. The first detection was less than a decade ago. It is like the moment Galileo first pointed a telescope at the sky. We are at the dawn of a new age of discovery, where we will map the universe not just by sight, but by its very vibrations. As our detectors become more sensitive, we will hear the constant background hum of the cosmos, the chorus of countless orbiting objects. We will be able to map the dark side of the universe, the population of black holes and other objects that do not shine. We are turning our ears to the cosmos and preparing to listen to the symphony of its deepest rhythms. We are tuning our instruments to the heartbeat of the universe. The entire universe is expanding, carrying galaxies away from each other on a gentle cosmic tide. This is the grandest stage on which relativity plays out. On the largest scales, we observe that almost all galaxies are moving away from us, and the farther away a galaxy is, the faster it appears to recede. This is not because of an explosion that sent everything flying outwards from a central point. It is because the fabric of space-time itself is stretching. Imagine a loaf of raisin bread rising in an oven. As the dough expands, it carries the raisins along with it. From the perspective of any one raisin, all the other raisins are moving away, and the more distant ones are moving away faster.
This is our universe.
We are on one of the raisins in a gentle, cosmic leavening. It is a slow, silent, and universal breath, taken by the cosmos itself. It is not that galaxies are moving through space, but that space itself is stretching between them. The galaxies themselves are not flying through space like cosmic projectiles. Most of them are relatively stationary within their local patch of space-time. But the patches of space-time themselves are growing, creating more distance between them. This is why some distant galaxies can be receding from us faster than the speed of light. This doesn't violate the cosmic speed limit because the limit applies to motion through space. The galaxies are not traveling through space faster than light. It is the space between us and them that is expanding at that incredible rate. It is a subtle but crucial distinction that changes our entire picture of the cosmos. The map of the universe is being redrawn.
Moment by moment, every point in the universe can feel like it is the center of this expansion. Because it is the fabric itself that is expanding, there is no center to this cosmic growth.
From any galaxy you choose, you would see all the other galaxies moving away from you. The universe does not have an edge or a central point from which everything is expanding. The expansion is happening everywhere at once. It is a profoundly democratic and uniform process. Our view of the receding galaxies is not a special one. It is the same view that any observer in any other galaxy would have. We are not in a privileged position, but simply one point within a vast, interconnected, and uniformly growing whole. There is no center, or perhaps everywhere is the center. The farther away a galaxy is, the faster it appears to be drifting away from us. This simple relationship, known as Hubble's law, is the cornerstone of modern cosmology. It is the primary evidence for the expansion of the universe. By measuring the redshift of a galaxy's light, how much its light has been stretched by the cosmic expansion, we can determine how fast it is moving away from us. And by measuring its apparent brightness, we can estimate its distance. When we plot these two values for thousands of galaxies, they form a clear and simple pattern. The more distant the galaxy, the greater its redshift, the faster its recession. This allows us to work backward to calculate the age of the universe and understand its history. The speed of the galaxies tells the story of the age of the cosmos. This expansion is a feature of space-time itself, a slow, deep breath taken by the cosmos. General relativity naturally predicts a dynamic universe, one that should be either expanding or contracting. When Einstein first formulated his theory, he was so troubled by this that he added a cosmological constant to his equations to force the universe to be static and eternal. He later called this his greatest blunder, especially after Edwin Hubble's observations proved that the universe was in fact expanding. It seems that the natural state of space-time on the largest scales is not to be still. It possesses an inherent dynamic quality, a tendency to grow and stretch like a living thing taking a slow, deep breath over billions of years. The universe's natural state is one of gentle, perpetual change. The light from distant galaxies is stretched by this expansion, becoming redder as it travels. This cosmological redshift is different from the Doppler shift caused by an object moving through space. It is a direct consequence of the stretching of space itself. As a photon of light travels across the billions of light years from a distant galaxy, the space it is traveling through is constantly expanding. This expansion gently stretches the wavelength of the photon along with it. A photon that was emitted as blue, high-energy light will arrive as red, low-energy light. The amount of stretching is a direct measure of how much the universe has expanded during the photon's long journey. The light itself is a ruler, measuring the growth of the universe. The theory of relativity provides the foundation for our understanding of the universe's birth and growth. Without general relativity, we would have no coherent scientific story for the origin and evolution of the cosmos. The theory provides the mathematical framework for the Big Bang model. It allows us to describe the universe in its earliest, hottest, densest moments and to model how it has expanded and cooled over 13.8 billion years to form the structures we see today. It explains why the universe is structured the way it is, and it allows us to ask deep questions about its ultimate fate. Will it expand forever, or will it one day collapse back in on itself? The answer lies in the grand cosmic competition between the outward push of expansion and the inward pull of gravity, a story told entirely in the language of relativity. It is the grammar of the universe's autobiography. We live inside a great, unfolding, four-dimensional structure. It can be calming to zoom out and see our place in this grand scheme. We are inhabitants of a vast, four-dimensional fabric of space-time that is currently in a state of gentle, accelerating expansion. Our lives unfold in a tiny corner of this structure, on a small planet orbiting an ordinary star in a typical galaxy, but we are connected to all of it. The expansion that separates the great galaxy clusters is happening in the space between the atoms in your room, though on this small scale, local forces easily overcome it. We are part of this unfolding, a piece of the universe that has, for a brief moment, become aware of the whole magnificent process. We are a momentary pattern in an ever-growing tapestry. Your position is not just a place, but a moment in the history of the universe. To truly locate yourself in the cosmos, you need to state not just your spatial coordinates, but your temporal one as well. You are here now. But this now is a specific moment, 13.8 billion years after the beginning. It is a time when the universe has expanded enough and cooled enough for stars and planets and life to form. It is a time when the universe is still young enough to be filled with brilliant, shining stars. We live in this fertile, temperate season of cosmic history. Our existence is tied to this specific epoch in the great, unfolding story. We are not just travelers in space, but travelers in a very particular
and very special time. You are a child of a
13.8 billion-year-old universe. The Mercury in old thermometers orbits the Sun in a way that can only be explained by the curves of space-time. Even within our own solar system, there are subtle clues that the old Newtonian picture of gravity is incomplete. For centuries, astronomers were puzzled by the orbit of the planet Mercury. Its elliptical path around the Sun slowly rotates or precesses over time. Newton's theory could account for most of this precession due to the gravitational pull of the other planets, but there was a tiny, stubborn discrepancy left over. General relativity explained it perfectly. Mercury is the closest planet to the Sun and orbits in the deepest, most curved part of its gravitational well. The shape of that curve in space-time accounts for the missing part of its precession. Even the smallest planets feel the deep truth of the universe's shape. Relativity is not just about the cosmos. It is about the precise tick of a clock in a quiet room. After our long journey through the cosmos, we can bring our awareness back to the here and now. The profound and strange laws that govern black holes and expanding galaxies are the very same laws that govern the space in this room. The quiet, gentle flow of time that you are experiencing is your own local slice of the great cosmic river. The gravity that holds you gently in your bed is a small, local curve in the same fabric that guides the planets. The theory is not something distant and abstract. It is the most accurate description we have of the very room you are in, the very air you breathe, the very moments that carry you towards sleep. The laws of the cosmos are present in the quietest of places. The golden ring of a gravitationally lensed galaxy is sometimes called an Einstein ring. When the alignment of a distant galaxy,
A lensing galaxy, and Earth is absolutely perfect.
the light from the background galaxy can be smeared into a perfect glowing circle around the foreground one. This beautiful and rare phenomenon is called an Einstein ring. It is a cosmic bullseye, a perfect projection of the deep symmetry of the gravitational lens. Finding one is like seeing the universe achieve a moment of perfect accidental artistry. It is a testament to the fact that the strange, warping effects of gravity can, under the right circumstances, create objects of profound and simple beauty, painting a perfect circle of ancient light in the night sky. It is gravity's halo, a crown of light for a hidden galaxy. The theory is tested every time you use your phone's map to find your way home. Let us end with the most practical and immediate connection. The Global Positioning System, GPS, in your phone or car relies on a network of satellites, each with a very precise atomic clock. To calculate your position, the system needs to compare the timing of signals from several of these satellites. But as we know, the clocks on those satellites tick at a different rate from clocks on the ground. They are in weaker gravity, which speeds them up, and are moving at high speed, which slows them down. Without applying the precise corrections from both special and general relativity, the entire GPS system would fail within minutes, accumulating errors of several miles per day. This grand cosmic theory is what keeps you from getting lost on the way home. The same laws govern the fall of an apple and the orbit of a distant planet. This was the great synthesis of Newton, and it is made even more profound by Einstein. The gentle curve in space-time that guides a falling apple to the ground is a miniature version of the vast curve that holds the Earth in its orbit around the Sun. And that, in turn, is a smaller version of the curve that guides the Sun's path around the center of the Milky Way. There is a single, underlying, and beautifully simple principle at work on all scales. Matter and energy curve the space-time around them, and objects simply follow the straightest possible paths through that curved space-time, from the smallest to the grandest motions. The universe follows one elegant rule. It is a universe of a single, simple, and graceful idea. Everything is simply following its most natural path through a hidden landscape. There is a deep and restful quality to this idea. Nothing in the universe is fighting against its nature. A planet in orbit is not struggling to stay aloft. It is in a state of perfect, effortless freefall. A beam of light bending around a star is not being forced off its course. It is following the most direct route available. All the motion and complexity we see is the result of objects taking the path of least resistance through a dynamic but invisible landscape. There is no strain, no effort, just a quiet and profound surrender to the local geometry of the world. All things are adrift on the gentlest and most natural of currents. The universe is not a stage, but an active, flowing, and changing entity. If there is one feeling to take away from our journey, it is this: the universe is not a static collection of objects in a fixed, empty box. It is a single, interconnected, and dynamic whole. The container and the contents are part of the same process. Space-time acts on matter, and matter acts on space-time. It is a universe that is constantly breathing, rippling, twisting, and expanding. It is alive with a deep, slow, and powerful form of energy. We are not just observers of this universe. We are participants in it, made of its substance and subject to its beautiful, flowing laws. We are part of a great cosmic river, flowing from one moment to the next. the simple elegance of these ideas has reshaped our view of everything. The journey from a clockwork universe of pulls and forces to a geometric universe of curves and currents is one of the greatest intellectual journeys humanity has ever taken. It replaced a mechanical view with an organic one, a rigid view with a fluid one. It showed us that the fundamental components of our reality, space and time, are not what they seem. They are pliable, personal, and intertwined. This new view, born from the mind of a single person a little over a century ago, has given us a deeper and far more beautiful understanding of the cosmos and our quiet, gentle place within it. It is a story that turned the universe from a machine into a poem. From the smallest particle to the largest galaxy, all are adrift on the currents of space-time. Let this be a unifying thought. The electron orbiting an atom, the moon orbiting a planet, the star orbiting a galactic core, the galaxy cluster drifting on the tide of cosmic expansion, all are subject to the same gentle guidance. They are all following the contours of the same universal fabric. There is a deep unity in all of this motion. Everything is simply finding its own unique path through the same shared reality, the same underlying landscape. All of the complexity and diversity of the cosmos stems from this one single principle playing out on different scales. Everything is floating together in the same invisible ocean. The force we call gravity is just the feeling of following these cosmic contours. Think of what it feels like to be in a car as it goes over a hill. You feel a momentary lightness as you follow the curve upwards, or the feeling of being pressed into your seat as you go through a dip. These are the feelings of moving along a curved path. In the same way, the persistent feeling of weight that you experience right now is the feeling of the Earth's surface preventing you from following your natural downward path along the curve of space-time. The force is an illusion. The true reality is the shape of the world and our interaction with that shape. Weight is just the feeling of the ground, holding you in place on a gentle cosmic slope. The mystery of relativity is the mystery of the shape of the universe itself. At its heart, this entire journey has been an exploration of geometry. It is a theory about the shape of reality and how that shape affects everything within it. It is a story of lines, curves, surfaces, and dimensions. It invites us to think about our universe not as a collection of things, but as a single, four-dimensional form with its own unique and evolving shape. The deepest questions that remain: what is dark matter? What is dark energy? What happens inside a black hole? Are all, in essence, questions about the true and complete geometry of our cosmos. We are all inhabitants of a beautiful, mysterious and unseen shape. We are travelers on a small planet, following a gentle curve around a star. Let your awareness settle here, in this simple truth. You are resting on the surface of a sphere called Earth. This sphere is currently moving along a great elliptical path, a geodesic, through the curved space-time created by the Sun. It is a journey of hundreds of millions of miles, completed once every year,
and it is a journey of perfect, weightless freefall.
We don't feel the motion because we and the atmosphere and everything around us are all falling together in perfect unison. It is a calm, stable, and predictable journey that has been going on for billions of years. You are on a gentle, cosmic carousel, turning slowly in the quiet dark. This star is following a wider curve around the center of our galaxy. Now zoom out once more. Our Sun, with its entire family of planets, is not stationary. It is on an even grander orbit, a slow, majestic sweep around the supermassive black hole at the heart of the Milky Way galaxy. This journey takes over 200 million years to complete one circuit. The last time our solar system was in this position, dinosaurs were just beginning to walk the Earth. We are all participating in this vast, silent, and ancient spiral, a river of 100 billion stars, all following the deep and powerful curve in space-time created by our galaxy's immense collective mass. We are drifting in a great, starry river on a slow journey to nowhere in particular, and our galaxy is drifting on the slow, expanding tide of the universe, and finally, our entire Milky Way galaxy. This vast island of stars is itself not fixed. It is being carried along on the great outward flow of cosmic expansion. Along with our neighboring galaxy Andromeda and a few dozen smaller ones, we are moving through the universe as a small, gravitationally bound family. But the space between our local group and other more distant galaxy clusters is constantly growing. We are adrift on the largest and most gentle current of all, the deep, underlying expansion of space-time itself, a tide that carries everything along with it. We are like a single boat in a fleet of billions.
On an ever-widening ocean, it is all one great, silent,
interconnected dance, from the tiny dimple in space-time created by your own resting body to the vast curve that guides our galaxy. It is all part of a single, unified system. Everything affects everything else. The motion of the planets, the shining of the stars, the expansion of the cosmos, and the flow of time in this very room are all different expressions of the same underlying dance between matter, energy, and the geometry of space-time. It is a dance of quiet elegance, of profound simplicity, and of interconnected beauty. You are a resting, breathing part of this silent cosmic choreography, and you are a quiet, resting part of this cosmic drift. So let your awareness come to rest here. Feel your body, held gently by the small, local curve of the earth. Feel your breath, moving in the quiet, local flow of time. You are a part of this great drifting universe. You are made of stardust, subject to the same gentle laws that guide the galaxies.
There is no separation.
You belong here. You are a way that the cosmos has become aware of itself for a brief and wonderful moment. And now it is time for that awareness to soften, to dissolve into a quiet and peaceful rest. You are a child of the cosmos, safely at home in the quiet night, and so our wandering through the vast night of space and time begins to settle. The currents that carried us grow still, and the distant ideas fade like stars at dawn. There is nothing left to do now but float in the quiet space that remains. We drifted through the silent fabric of the universe, feeling its gentle curves and ripples. We listened to the river of time, flowing fast in one place and slow in another. We watched as starlight, ancient and patient, bent its path to bring us messages from a deep and distant past. We felt the whole cosmos as a single, breathing and interconnected whole. The same gentle laws that guide the planets in their silent orbits are present in this room with you now. The same fabric of space-time that holds the galaxies rests quietly around you. The same atoms that were forged in the hearts of dying stars rest gently within you, dreaming of their long journey. So now let yourself drift fully into sleep. Let go of the journey and simply rest in the destination. Be carried like a leaf on a quiet current, or a mote of dust on a gentle beam of light. There is only peace here.
There is only rest.
Good night.